All right, it looks like folks are connecting. We'll wait here a second for everybody to be to join. I see some old friends and some new friends. Welcome, everybody. All right. Uh, the rate of joining seems to have slowed down, so maybe we'll kick off. Um, welcome to today's IFHE Global Webinar titled "Why Are So Many New Hospitals So Energy Inefficient?" My name is Walt Vernon. I'm honored to serve as the president of the International Federation of Healthcare Engineering. Um, you know, the purpose and mission of IFHE is to share knowledge and to make available the things that we learn and the best practices from around the world to other people in other countries. And so one of the things that we've recently begun is this series of webinars, and we're quite excited to be able to do that. The webinars are really intended to advance our mission of sharing knowledge and widely disseminating it. So one thing I want to do is invite all of you who are on today to remember that you have the opportunity to present the work that you're doing around the world in future upcoming webinars. So I hope you'll be in touch with us and help us to continue to build our global community. I do want to note that today's webinar is supported by Mazzetti. Mazzetti is an employee-owned benefit corporation uh, with something like 6 or 7 decades designing health facilities and with offices in the US, in India, and in Africa, and practicing globally. So thanks to Mazzetti for supporting the program. Before we begin, I want to remind everybody that Zoom, this is very important, Zoom offers closed captioning and live subtitle translation in multiple languages. You can access these features through the captions and translation options located at the bottom of your Zoom screen. And so this diagram is trying to tell you how to do that. I hope it does. By the way, if anybody has problems with that, maybe put a note in the chat because we want to help people to overcome our collective language barrier so that we can more effectively communicate with one another. I'm hoping that someday AI fixes all of these problems for us. And that reminds me, sometimes people tell me that I speak too fast, especially for non-English speakers to hear. So we will try to pace ourselves today. And if we're speaking too fast, please add a note in the chat so that we can modulate. All right. Today we will be using the Q&A feature. And so I invite folks to type questions in as we go. We have reserved some time at the end of the session to answer as many questions as we can. And it will be a much richer conversation if we're able to address the kinds of things that you're interested in. Today's webinar is intended to look at the actual energy use intensity of recently opened and planned hospitals, to identify why new hospital development processes don't always give us the kinds of outcomes that we aspire to, and to think through how to set targets and commission them as they open and manage them in order to achieve the energy performance we want. And then to look at ways that we can collectively, as a community of peers around the world, work together in ongoing research to achieve better energy performance in every hospitals. I want to introduce our speakers today. First, we have Mr. Ian Jarvis, President of the Climate Challenge Network, one of Canada's leading experts in building energy performance, sustainability, and decarbonization. Ian has more than 3 decades of experience. He has worked with governments, healthcare organizations, municipalities, institutional building owners to help with energy efficiency and climate action initiatives. He is a founding chair of the Canada Green Building Council. He has led numerous national research projects focused on improving building performance. He is widely recognized for his work in healthcare decarbonization, high-performance buildings, and sustainable communities. Joining Ian is Amandeep Dole, Vice, and I apologize if my pronunciation, I should have practiced earlier, my apologies, the Vice President of the Climate Challenge Network. Amandeep leads technical initiatives focused on healthcare energy performance, decarbonization, and operational optimization. He's experienced in energy planning, recommissioning, building automation systems, ventilation optimization, heat recovery, electrification, commissioning, measurement, verification for healthcare and institutional facilities across Canada and the US. Through the Climate Challenge Network, he leads collaborative research efforts that help healthcare organizations improve both environmental and financial performance. I want to thank Ian and Amandeep deeply for being here, and the floor is yours.
Thank you, Walt. And here come the pictures. And thanks everybody on the call for making the time for this, what we think is an important subject around the world. Countries are spending a lot of money. Everything is relative in different parts of the world, but a lot of money on new healthcare facilities. We also are running a large number of existing and older facilities. Our belief is we got to get the new ones right to help inform us on fixing up and decarbonizing the older ones. So the context of this energy efficiency, I know means different things in different parts of the world. The context for this presentation is primarily hospitals across newly opened hospitals across Canada and in the United States, with some representation from the National Health Service in the UK. So these are all generally built to ASHRAE standards. So that is the context for the conversation we'll have today. The title speaks to itself. There's so many new hospitals, despite new technology and new ideas that are not turning out to be as energy efficient as they should be. And our collective task is to make sure that with new hospitals, with the investment that go into them, we get them right the first time. So that's what the conversation from Amandeep and myself today will be all about. The next slide, please. As Walt mentioned, my name is Ian Jarvis. I'm the Executive Director of the Climate Challenge Network, which is a large and growing nonprofit organization focused on these areas for different kinds of public buildings across North America, joined today by our Vice President of Engineering, Amandeep, who will be speaking in particular to what we've learned from the best performing new hospitals and what we've learned about the hospitals that didn't turn out as well as planned or as expected. Next slide, please. So the storyline or the agenda for the day will tell you just a little bit about greening healthcare, who we are, looking at some exceptionally energy efficient major acute care hospitals that have opened in the past 15 years. I'm going to spend some time looking at three case studies. Amandeep will walk us through three case studies of hospitals that turned out not to be so energy efficient. And it's the key question: what went wrong and how can we do things better on a go forward basis? I'll come back then to lessons learned. What do we think we're learning? What advice can we put out there for your consideration in terms of the process by which new hospitals are conceived, built, and put into operation? And we want to close with, why do we do this work? And I believe anybody on this call will have a commitment to the urgency the responsibility to take action around climate change and energy efficiency in big buildings like hospitals we see as a significant contributor to bending the curve on greenhouse gas emissions. And as Walt promised at the end, we're going to make time for audience Q&A. I truly hope that people on this call will think about if and how these issues, these ideas apply to them and will be willing to ask the question most easily in the Q&A chat. But otherwise, we'll open it up to people to ask questions directly. So this is what we hope to get through in the 1 hour allotted to this. Next slide, please. Briefly, Greening Healthcare is a large and growing nonprofit. We have close now to 100 member hospitals across Canada and in the United States, as it says here, working together on energy efficiency, operational energy efficiency for hospital facilities. The working together looks like this. The hospitals, we talk about strategies, we talk about best practices, we talk about case studies. As Walt mentioned, we set targets. We tell people how much energy and utility costs they can save by getting things right. And please do visit us at greeninghc.org to learn everything about the program, the events that are coming up, which Amandeep will mention at the end of this call, which everybody's welcome to join in on. And we have some thoughts about hopefully collecting some of the data that you may have on some of your energy efficient facilities that we can profile in an in-person event coming up in November here that brings people together from a lot of different locations to talk about these things. Next slide, please. Part of greening healthcare is research. You heard that in our bios. We work with members. We help them make improvements. They ask questions. We answer those questions, or we connect them with other organizations that can. And every now and again, there are questions that we can't answer. We've been working on the energy efficiency of new, recently built hospitals. 2010 has been the demarcation point. And these are publications you'll find on our website. Please take a look at them. On the right here is the case study of Humber River Hospital, which we'll look at today. On the left is a collective analysis of a large number of recently built hospitals across North America and again in the UK. And the metrics that we'll share with you in a moment, they're documented in the publication in the middle there. Design teams everywhere involved in new hospital developments are using these metrics to calibrate their energy models and set the targets based on empirical data, based on best practice, empirical data that can help everybody get as good as some of the examples we'll give you today. Next slide, please. Greening healthcare is built around data and built around benchmarking. And we realize that energy sources are different in different parts of the world, and the availability of these kind of data varies between different jurisdictions. But every horizontal line on this benchmark chart, this ski slope, if you like, is an individual hospital. These are new and existing hospitals. The blue part is the electricity use per square foot, the electricity use intensity. The orange is the thermal. Typically in North America, natural gas, some fuel oil, and we understand there are other heating energy sources out there. The most efficient hospitals are at the top of this chart. Those are the ones we study, and they're summarized in the little table in the middle there. So the best performing hospitals come from different parts of North America. You'll see several coming from the United Kingdom. Those we study and we share the findings with everybody else with a view to raising the water level for everybody. For interest, if all of the hospitals below the top quartile were to reach the top quartile, it reduces energy use and greenhouse gas emissions by more than 30%. And our findings, our experiences that those kind of reductions can be achieved primarily through operational improvements, not requiring major capital, not requiring significant decarbonization, heat pumps, rebuilds. This is just by running what we've got better. The other factor I want to raise here is certification is not an assurance of high performance. We find little correlation in these data between certifications and actual performance levels in terms of energy efficiency. Next slide, please. So let's talk about new hospitals, the idea of getting it right the first time. What kind of targets should be being set, which could be weather normalized to different parts of the world, and what kind of actual performance results we're seeing. Next slide, please. Here is a subset of the chart we looked at just a moment ago. The energy intensity units are kBTU per square foot, the US units. This comes from a presentation we gave to ASHE, the American Society of Hospital Engineers, 2 years ago. And we profile here two particular hospitals. Humber River Hospital, if you Google the most energy efficient hospitals in the world, you'll find Humber River, which is just to the north of Toronto here in Canada. You'll find it's profiled as number one. Cortelucci Vaughan is younger. It came on stream sooner. It learned its lessons from Humber River and pretty much replicated its performance. So these are two, but all of the hospitals on this chart are both new hospitals, open since 2010, and most of them since 2015, and all of them are LEED certified, just for interest. So we're going to focus on Humber River and Cortelucci Vaughan here. Next slide, please. Good thing about these hospitals is they're quite significantly sub-metered, so we've got a pretty good idea of where that energy is being used. And these are the metrics we've adopted based on Toronto weather, Toronto 2019 weather conditions. An energy target we think is readily achievable with current technology is 100 kBTU per square foot. And this is the breakdown between electricity use and thermal energy use. And this guide is being used again by design teams now across North America to calibrate their energy models. If this is best practice, are we designing and planning to operate hospitals to these kind of energy levels? So this has been a big step forward in terms of calibrating energy models and then looking at actual performance after the fact. The next slide is the same for a continuing care hospital. So this would include complex continuing care, mental health hospitals, those kind of facilities. The numbers are lower, 65 is the path there. And I just want to bring Amandeep in for a moment as to what you've seen when you study these and other high-performing hospitals as being the key factors that are leading to these good results. What made the big difference?
Yeah, I think as Ian said, we'll talk more about that as we sort of discuss the high performance. But the key thing with this data that we were able to kind of work throughout on the research, working on the recently built hospitals in the last 10 years, this is empirical data that helps to kind of now able to calibrate the energy model, which was previously not there. A lot of the times, energy models done in these facilities were based on taking assumptions on plug load, as an example, assumptions on knowing how much the process load is and what amount of that process load in turn turns into energy that could be reused in the building. But with the empirical data, these recalibrations now accurately could reflect the energy model use and then able to predict those energy use down in the future. So the key thing, as you pointed, what is a success story? It starts with setting the right target, and that's where things have started right for the hospitals, which have been able to accomplish this sort of numbers, is that their vision started with the right target and not that translate into the component energy use and comparisons for those hospitals.
Thanks, Amandeep. And hopefully some questions are forming in people's minds right now. And again, feel free to write them into the Q&A. And we will be asking you directly at the end of this for what areas you'd like to dig a bit deeper in and what your experiences may be. Next slide, please. Got to understand first, this is not an economic issue. It costs less to build more energy efficient hospitals. Looking at the high performance targets that are suggested by this work, we looked at all the other hospitals and said if they were to meet those targets, how much energy would they save? You can see with some of these hospitals, it's well over 50%. They're using more than double the amount of energy that they should be with technology and practices that are available today. All the red ones are using too much energy. And the table on the right gives the reality that it's costing about $1 million a year for each of these hospitals to be running that way over 30 to 50 year life cycle. These numbers are huge and significant relative to the cost of the facility. So it's a different process required. It's not spending more money to achieve high energy performance outcomes. Next slide, please. So we mentioned Humber River, and you'll find profiles of that on our website. And Newsweek publishes the list of the top 10 most sustainable hospitals. You'll find Humber River within there. But let's go on to some of the stories of Cortellucci Vaughan, which is interesting because they started from the experience and the results achieved at Humber River. Next slide, please. This is a major acute care hospital. It took over. It's one of the fastest growing regions of Canada, just north of Toronto. It was the only big city in Canada that didn't have its own hospital. So the Cortellucci Vaughan Hospital was added to their Richmond Hill site, and the blend between them, this gives an idea of how it is going. So this is a new hospital serving a rapidly growing part of a rapidly growing country in Canada. Next slide, please. I won't read these through. The hospital came into operation in June of 2021. You can see the size, some of the history in there. It was a P3 project where a separate contractor both designed, built, and is then operating the facility over a 30-year contract term. Next slide, please. And this is a best practice. They started at the outset with impressing upon the team this set of principles, one of which, as you can see, was they wanted to be sustainable, they wanted to be green, but they very much looked at what are the key principles here that we require from every team member, the contractor, the designer, the engineer, the operator, the facility manager. What are these principles? And those were reinforced throughout the multi-year process of bringing this hospital into being. Next slide, please. And these principles reflected in ongoing daily practice that became the norm for the whole team, walking the site on a regular basis, making sure things the way they're supposed to be. The kind of analytics coming from the building automation system, constant checking back in on the decisions being made on a day-to-day basis, were they helping or maybe getting in the way of the ultimate energy performance. So operational vigilance throughout the design and construction and handover process was a critical part of the success. Next slide, please. And electricity, the hospital started off pretty well. This is the tracking that the hospital uses. The blue dots are monthly utility bills. The red dots are the weather normalized baseline. The electricity was a bit lower in that first period because one of the heat recovery chillers failed and wasn't working very well. But generally, the blue dots, the high electricity performance was in place pretty much from day one. Next slide, please. Not so much the thermal energy. So you can see the The baseline again is the red dotted lines, and you can see the period when the heat recovery chiller was not working well. The gas consumption rose mightily. So small electricity savings, very big gas increases. A lot of thoughtful and intelligent work went into getting the plant running the way it's supposed to be so that by year 3 and by year 4, these numbers are good. And the red dots highlighted 3, or the red circles highlighted 3 and 5. They're still working on this. There's still areas where they think improvements can be made, even beyond the numbers we've shared already. So it's an intensive startup period and it's ongoing continuous improvement. Next slide, please. We pass this over to Amandeep. So we're looking at 2 hospitals which are the most energy efficient acute care hospitals we've found so far, and we're hoping that somebody on this call has some that are even better that we can profile in future. But let's look at the other end of the chart and Amandeep walk us through what did we find, what went wrong with the hospitals that did not turn out so well.
Thanks, Ian. Yes, there's always a lot of lessons learned through these projects. So how it started was we looked at hospitals across Canada through the research projects documenting um, that are recently built in the last 10 years, which would provide us the information around these hospitals that would help us to kind of understand why some of these are underperforming. So on the left-hand side, you see a chart which kind of shows the savings potential for these hospitals. And then these are all recently built hospitals in the last 10 years. So we picked the case studies around 3 of them at a different sort of jurisdictions across Canada. So the hospital 1, 2, and 3, they represent recently built hospital and has the highest savings potential among this group. So as you could see, there's savings potential across electricity, thermal, and it is a similar story for these hospitals which were recently built. However, they were built with a vision to be high-performing hospitals, but they did not turn out to be high-performance hospitals against the data that's we looked at. So the case study 1, it's the hospital 1, which is one of the rural hospital in Ontario, Canada, one of the provinces. It's about 130,000 or 150,000 square feet, was built recently in the last 5 years. With all of these hospitals, the infrastructure, what you would expect in a new hospital to be top of the line. So in case of the ventilation systems, the air handling units were equipped with variable frequency drives to enable the setbacks. There were enthalpy wheels to enable the heat recovery on the ventilation exhaust. The hospital was designed with the low temperature heating loops, which provided them with an opportunity to work with a heat recovery chiller to maximize the efficiency. The hospital had condensing boilers. Steam boilers were only used for high pressure steam load, which is sterilization in the hospital. Um, and even after all of the infrastructure, the hospital still turned out to be an inefficient hospital compared to the hospital that are in the same database that we previously showed, which were built like 30 or 40 years ago. And this hospital couldn't even meet those energy numbers for the hospital that were built 40 years ago. So what happened? What went right from the design perspective, it had all the elements that is needed for a high performance hospital. So in terms of a design, this hospital had a similar design for the Cartolucci one or the Humber River Hospital, which are a high performance hospital. However, things went sideways during design, also during the construction as well. So um, there are challenges with the design. So the condensate tank, as an example, was undersized, which kind of resulted in not efficient recovery from the condensate tank. But the main things that are happened, like it was also during construction as well, the system clean out and flush out wasn't there. But in the commissioning phase, it was the heat wheels which were supposed to be set up to recover the ventilation exhaust energy. They were set up incorrectly, and the set point was too high. It resulted in disabling those wheels, and that energy could not be recovered. Similarly, the heat recovery chiller which is a very sensitive equipment, typically in a hospital configuration from an operations side. If it's not run at a proper temperature, which is it designed for, it generally gets either causes operational issues or results in inefficiency. So in this scenario, the heating loop, which was set up, were operated too high, which basically disabled the heat recovery chiller. And without the heat recovery chiller, all the waste heat from a 24/7 load was basically rejected outside the atmosphere instead of being used within the building. And last but not the least, the operations is a critical success to all of these case studies is that these hospitals were originally designed, even in the energy model, to have these air handling units, ventilation systems to be set back or scheduled off for spaces which are not occupied 24/7. However, in operations, that didn't happen. Everything ran 24/7. And as a result, there was an increase in the ventilation energy, there was an increase in the heating and cooling energy for the system. So these are sort of what went kind of wrong from where you see these hospitals. So the second hospital, it's in a different province, Manitoba, which is primary heating dominated province, about 184,000 square feet. In addition to all the other features in this hospital actually also had a geothermal system installed, which means that you can further extract or reject the heat from the ground source to enable you to do even better on your energy efficiency. However, the result was that this hospital still turned out to be inefficient with all the infrastructure in place. So what happened in this, what went right was exactly what was in the previous hospital, that the design included all the elements that you would see correctly. However, the things went wrong was around the complex design as a starting point. So on the design itself, the hydronic loop was made too complex that neither building operations team were able to understand how it was fully utilized. And as a result, the key component of where the energy use would have been reduced to heat recovery chiller operations basically got disabled because that information from the knowledge from the design team did not get sort of passed on to operations team in a way that they completely understand how the system was designed, what was the original intent of the design, and how that translate actually to operations. So the gap of that resulted in that nobody understood how this heat recovery chiller was supposed to be operated in that complex hydronic loop design system, which pretty much then the operator turned to the safe side, which was to ensure that the building was working. And then the way they did that was easily to disable the heat recovery chiller, which then they were not able to recover any heat as a result of it. The geothermal loop, which was supposed to provide that additional source of heating, sink and source, was installed under an asphalt parking lot, and it was installed in a way that it basically wasn't able to be used as a source or a sink because it was too close and the ground temperature were too high in that neighborhood, and then the geothermal loop got disabled as a result of that. Um, the other thing, similar operations thing, which is basically same for most of the underperforming hospital, is that the HUs, their handling units, they're typically designed for to have a setback schedule. However, they generally get operated 24/7. So that was kind of a missed opportunity which happened in this hospital as well. And then in addition, the perimeter pumps, which ran in summer, which basically resulted in simultaneous heating and cooling in the system and increasing the cooling as well as the heating energy in the building. Hospital 3, a large kind of a rural acute care hospital, 690, almost 700,000 square feet hospital, and was built similarly in the last 5 years. It had all the features of the other hospitals like VFTs, enthalpy wheels, condensing boilers. However, one of the things that's different on this hospital because of the design requirement that this hospital did not have a heat recovery chiller. So, which becomes a fundamental difference in the design from a high performance hospital when you don't have a heat recovery chiller. In that scenario, all your 24/7 load, which is reclaimed from your 24/7 systems like MRI, CT scanners, it get ejected outside to atmosphere versus using a heat recovery chiller to reclaim that and put it back into the building, eventually lowering your gas consumption in the building. So that was one fundamental design difference for this hospital, and it basically started from the specification that were issued. So the specification in the hospital one and two had the requirement to have a heat recovery chiller tied to 24/7 load, whereas in hospital three, that requirement wasn't there. So the consultant and everybody else designed that hospital with no heat recovery chiller. Other things that were prominent in this particular hospital was that the enthalpy wheels did not work as expected. They were positively pressurized. As a result, there was a big leakage since they were almost 5 inches positively pressurized, which resulted in air leakage. And as a result, they had to turn on their extra air handling units beyond, which was typically should be used as a redundant unit, but they couldn't meet the air handling unit air change rates with this configuration of the HUs, and they were able now their systems are running at a higher ventilation or watts per CFM as a result. Similar issues around Telpe wheels and AHUs working 24/7. The preheat set point on these coils were set too high, which basically disabled the heat wheels, and as a result, they're not able to reclaim any of that waste heat in their system. So I'm going to bring Ian to this. So these are so far the lessons learned. And Ian, do you want to take over and then talk about those lessons learned?
Yeah, thanks. Let's talk about lessons learned. Like, what are we learning from this? It's ongoing research. So we're tracking all of these facilities over time, and some are making corrections and improvements. But high-level principles that this net zero, low carbon strategic lens being behind every decision that gets made, that energy efficiency, the operational aspects are all the operations controls, those always come first. That there are some basic principles about HVAC system design to be followed. What set Humber River and Courtney Vaughan apart from many other hospitals was this integrated team-based approach. Everybody was together. They all understood the goals. And the workshop that we held in September 2024 to profile this, if you're interested, you can find the recording at the link that is provided on the slide. It's a whole day of proceedings, but you'll find it's been broken up into sections on different parts of the team. I'll come back to that in just a moment. But a lot of lessons being learned, and we need to learn them to make sure we get consistently good outcomes in future. We spoke about energy efficiency first. Amandeep mentioned that the biggest single factor setting the high performers apart from the lower performers is running things when there's nobody there. There's every part of the hospital lends itself to zoning and scheduling, and making sure that is built in from the outside is key. And Amandeep did a great job of covering those things. And you can find two previous sessions on the Greening Healthcare website from events in the past where we've talked about these things. How do you get operational factors all lined up so things work consistently well? And next slide, please. We talked about the design factors. They're summarized, I think, very effectively here. All of the things in red are the ones that we found are most commonly associated with underperforming hospitals. These are things you've got to get right, all the way from setting the targets to designing things correctly to commissioning them properly and handing them over and making sure the operating staff knows what they have. The Greening Healthcare is doing a lot of work on engagement of clinical staff. We're finding a lot of the push for sustainability is coming from hospital staff, from the medical departments, from the clinicians. During the construction, the process really matters. Inspection really matters. The tab contractor, the testing and balancing contractor, the work they do, it really matters. Next slide, please. Commissioning is everything, taking the design intent and making sure the systems are performing the way they're expected to. The sub-metering in these hospitals was a big deal. When it's designed in from the outset, it's a relatively low cost. So we love metering as a means of tracking down when things go wrong, what went wrong. And finally, this whole area of the key things around facility operations. HVAC systems drive the energy use of all of the hospitals. We look at these four factors, these four aspects of those through the life cycle of the project development. These are critically important. Next slide, please. So I believe that IFHE will be sharing the slide deck with you, so you don't have to scribble all this down, but we try to break this into what does a new integrated development process look like, where everybody shares the vision at the outset and it's front of mind right through the whole process. So these planning design part, the procurement part, construction, commissioning, handover, and ongoing facility management. The high-performing hospitals got all four of these stages right and ended up with step 5 here, which is the highly energy efficient hospital. We know how to do this. We need to do it consistently well on a go-forward basis. Next slide, please. So I mentioned the idea of teamwork, people being together. Once again, we provided the recording link at the bottom here. It's the same event. These are 2 of the panels that were on that all-day event at Cortellucci Vaughan Hospital. People coming from the service provider, from the owner, and Amandeep moderating this particular session. So it's worth listening to that panel discussion for if like the story behind the story, the things that you can learn as the issues and the opportunities were debated at that event. So this is from that 2024 all-day workshop. And same on examining lessons learned. We've got executives from hospitals, from service providers, and from design teams. And Tony Palesci was particularly helpful in terms of this is what worked well for them. This is what they would do differently next time. So this becomes a learning process. Next slide, please. So that really is the story of where the high-performing hospitals, how they came to be, and how the underperforming hospitals went wrong, and the work continues to fix the underperforming hospitals and make sure that the what went wrongs never happen again. But wanted with this particular audience to share a few thoughts coming out of our annual forum each year that why are we doing this? Why does it matter that new hospitals be energy efficient? Why are we proposing that many organizations do things significantly different to get consistently good outcomes? So this, for all of us, is a call to action. This is what drives us. And we got key elements coming out of this. So the next slide, please. So we see increasingly the effects of climate change around the world. Our keynote speaker at the 2022 Greening Healthcare Forum, and we have the 2026 edition coming up in November, was Dr. Ronnie Cohn, just a powerful speaker, the CEO of this Hospital for Sick Children in Toronto, who connected climate change to 85% of children's illnesses, both in North America and around the world. And that's what drives the Hospital for Sick Children, as this is a moral and a core imperative for them to get this right. Next slide, please. You can also hear the recording, and all of these are on the website, from Dr. Penny Ballum, the board chair of Vancouver Coastal Health, a recognized leader around sustainability and healthcare, a former deputy minister of health in British Columbia, former city manager at Vancouver. And she spoke movingly about seeing her hometown of Kelowna burning. And guess what? It's pretty close to burning again this year. And how she then understood climate anxiety. What does that feel like? And why is it so urgent that we all deal with this. Her presentation, her keynote was titled Running Out of Time, and she made a very compelling case. We are running out of time. We need to deal with this. Next slide, please. And we speak all the time around these three key words. This is urgent. Climate change can't wait until we get other things fixed up. It's relentless. It's continuing. It's a great opportunity for leadership. We love all the leaders we work with that are stepping out, and it's a responsibility, especially for healthcare, to deal with it. Climate change is the defining issue of our times. Governments can't fix it. We're not on track to meet targets, and every hospital has a role to play in closing the gap and doing everything that we can do. And new healthcare facilities are at the center of that conversation. Next slide, please. So we have an invitation, a challenge, I guess, an opportunity for everybody on this call. We have a number of remarkably energy efficient hospitals that we're working with. We want to find more, frankly. We will learn everyone that we've looked at, we've learned from, and the ones who aren't doing so well, we've learned even more from them. And at a global, certainly at a North America level, and we think at a global level, going back to Walt's original comment, sharing knowledge, sharing understanding, sharing best practices, that is an opportunity and a responsibility for the healthcare sector as a whole. If you have a hospital that's opened since 2010 that you believe is among the higher performers, send us your data. Michael's address is there. We will process the data. We'll compile it into these charts. It will be done confidentially and anonymously. We never shame anybody. We simply try to help. And our November the 9th annual forum, we plan to introduce, with your approval, globally, internationally, which are the top performing hospitals and what can we learn from them in 2027 and beyond that can help us, again, raise the water level for everybody, improve the standards of energy efficiency around the world. So this is open invitation. Please get in touch with us, send us your data, and let's add to the conversation, add to the best practice views that we're seeing. So next slide, I think we're going to pass it to you, Amandeep, to hopefully have some feedback from the people on the call, questions you may have, ways that you can get involved, or good experiences that you have. And Amandeep, over to you to close this out.
Thanks, Ian. Yeah, this kind of opens up anybody online. Please feel free to share, type your questions in now. We have a couple of them which I will address, and then if you have any remaining time, we can discuss some of the other items. So we got one question around from Stephen around how a particular challenges the controls and the commissioning happen so close to the end of the construction schedule that the construction team is pressurized to get it done. Do you recommend any how to address these issues? Thanks, Stephen. Yes, this is very common for us to see. What you pointed out is that, especially with the hospitals which are built with either design build finance or just built on a bid spec basis, typically the role of everybody in the end as it gets to is to kind of close the project as soon as they can and then hand over the things in a state which is called an operation state. But it's not an optimized state in most cases. So what typically happens is that when that hospital gets handed over from an operations state, um, and it does pass on that operation states to the operating team, which then typically operate the hospital in the same way. So the gap here is that the missing opportunity here, which we talked about in lessons learned, is that typically the commissioning work is focused on functional commissioning, which is to check equipment, whether it's turning on and off. And it's not based on a performance commissioning, which is to actually check whether your air handling system, for example, are getting set back as they were originally designed and modeled in the system. So either there's a gap in the specifications to start with from the owner's side to ensure that the performance commissioning is one of the tasks in the whole process, or it's completely kind of missed in that scope. Even the commissioning agent is still working on a functional commissioning rather than a performance commissioning. So it's not a rushed activity to sort of optimize these systems. This becomes then a process change at the start of start of the design, and even prior to setting up those performance requirement for the hospital. The the key thing around ensuring that the specification calls for operating sort of operations calls for um, those performance specification in those systems. So that would help to bridge that gap that you typically see in the system. There's another question about, do you see any issues on indoor surface condensations? Would it be seasonal, especially for a mix of AC and non-AC? Typically, hospitals in North America, they're designed to ensure that the surfaces that are expected to see condensation are protected by insulation, so that issue generally doesn't arise in most of those cases. And most of the hospitals are conditioned spaces in most cases. There's very few spaces in here where we have issues with no conditioning, but this condensation issues could happen if your surfaces are not protected as a result of insulations. Okay. Are there any other questions? We
I'm
are
going
still
to jump in and ask a couple of questions if I could.
sure.
I will note that I want to reserve a couple minutes at the end, Amandeep, for closing remarks.
Sure.
Um, I am wondering, one of the things you all talked about was that a big source of waste is things that are running when they don't need to.
Mhm.
ASHRAE has done some recent research sort of looking at this issue around large medical equipment, and which has a double impact because not only is it consuming energy, but it generates heat that then takes other energy to remove from a space. I'm wondering what you have seen in terms of turning off and control of large medical equipment in buildings.
I will address that two part. There's another question similar to that. I'll tackle both of them at the same time, which was around AHUs. And your question, I think, Walt, was around medical equipment, if I understand correctly. So I'll address both of them. So the questions around how much savings can you expect by optimizing the 24/7 operations of air handling units is totally dependent on the site EUI. But typically, we see if the hospitals typically are expected to save anywhere from 20 to 30% of their energy by operating these systems um, to the optimized design levels, which is typically to set them back when they're not required or to shut them down for spaces where it's like an admin occupancy. So those systems could be scheduled off, whereas systems where you have a clinical requirements, those systems are typically set back when there's no occupancy. So the savings you could expect on those could be anywhere from your consumption dropping from 20 to 30%, depending upon how your systems are originally set up. Your second question about can we turn off the medical equipment and how much savings do we get out of that? When you look at the energy used in a hospital, majority of the energy is coming from the ventilation systems and the chiller plant. So the medical equipment is a component, which is a process load when you see it in the component breakdown. So the process load is about 5 equivalent kilowatt per square foot of a total of 30, right? So there is an opportunity, but it is again, it becomes complicated where now you have to deal with the medical equipment folks and everything else. So our recommendation would be to prioritize the HVAC system first before you go to the medical equipment, because you get a much more savings through optimization of HVAC systems compared to optimization of a medical equipment, which then becomes a different discussion to start with.
Well, I might take objection to that, but I'll put that aside for another
Sure, no problem.
seminar. At this point, with only a few minutes left, I do want to close by just making a couple of other, oh, well,
So
there's
I
one.
just have a one more slide, Walton, and then I'll pass on to you.
Oh, you have one more
So
slide. Okay,
yeah.
okay, sorry.
And this is the 2026 event. So for folks on here, so if you are able to attend the webinars, is a complimentary. So these are the next scheduled webinars. You can always send an email to Michael. Then if you want to sign up for these webinars, our in-person event is on November 9th. If you're able to make it, that's going to be great. It's in Toronto, Canada. And if you need more information about these events, you can always reach out to us through these contact information, or you can also visit us on the Greening Healthcare website. Back to you.
Well, thank you, Amandeep and Ian, for your time and your and sharing what you've learned here. This is really, really helpful, I'm sure, to the IFHE audience. I will note just a couple of things. We got a whole bunch of questions after we sort of got to our end point. And so one of the things that we'll do is get these questions to Ian and Amandeep so that they can answer them in writing, and we'll send it to all of the attendees here so that you'll have that. And somehow, somebody asked about recordings of the sessions. And IFHE has recorded all of our webinars, and the recordings are all on the IFHE website. So, yes, this one will be available in perpetuity. However, I will say that we're in the process of updating our website, and probably the recordings will be put into a members only section of for IFHE members. So being an IFHE member is highly encouraged. And if people have questions about how to do that, obviously let me know. Um, all right. The one other thing I might note here about energy data is that IFHE has for about a decade now run a program to recognize and reward hospitals around the world for their energy efficiency programs called Cut the Carbs. We just closed the entries for that for the next upcoming set of awards, and there might still be time to sneak some things in, and maybe we could figure out some data sharing possibilities or something. Um, uh, so anyway, thanks to everybody. I do want to note that before we sign off, we are inviting everybody to our next webinar. The next webinar will be held on September 9th. It will be presented by Mr. Gunnar Hansen with Healthcare at Omega 365. This session is called Data-Driven Decision Making Across the Hospital Asset Lifecycle. It will showcase the ways Norwegian hospitals are connecting project, facility, and asset data through a single digital platform to improve decision-making across the building lifecycle. Through live examples, attendees will see how BIM, BMS IoT systems, and AI can help healthcare organizations improve performance, maximize existing facilities, and make smarter investment decisions. We hope you will join us on September 9th for what promises to be a fascinating discussion on the future of data-driven healthcare asset management. And I want to just close by thanking again all of the people who have helped make this webinar possible, certainly Amandeep and Ian, and a whole team of IFHE volunteers who give generously of their time to make this happen, to Mazzetti for sponsoring it. And I do want to extend the invitation to everybody who's listening to share what you know with the global audience through this IFHE webinar series. So thanks to everybody. I wish you the very best. And if you can't get enough, we're actually going to repeat this webinar in a few hours to catch some people in other time zones. So you could get another bite at the apple if you wish. With that, I'll wish everybody a fond farewell and look forward to seeing you at a future IFHE webinar. Bye-bye.